And with this one, we're going to get some more practice again. So the basic function, y equals, it's always going to be something to the power of x. Well, that only base number there is 2, so obviously it's going to be 2 to the x. Alright, so now let's list out the transformations. Let's go in order. So go to that exponent. Is there anything happening up here in the exponent? Well, there's only one thing. There's a half being multiplied to the x value. Remember, we always do the kind of the opposite of thinking. So this is going to be a horizontal stretch this time, because we're going to multiply the x values by the reciprocal of that number, which is the reciprocal of 1/2 is 2. Okay, so that right there takes care of everything inside the function. So now we're going to go to outside the function, and we've got to go in correct order. Is there anything being multiplied to the front? Not so much. Is there a negative sign out front? Yes, there is. So we're going to reflect over, and this time we're done with the horizontal, so now we're doing vertical, so we're going to reflect over the x-axis, or switch the signs on the y values. And the last thing we're going to do is go up 3 units. Oops, if I spelled their units correctly. So what that's going to do is we're going to add 3 to the y's. Okay, let's start with our original t-chart. And again, we're doing a basic exponential function, so the domain of a basic exponential function is all real numbers, so let's include everything in here. And I'm just graphing the basic function. So 2 to the negative 2, take the reciprocal of that base, so that exponent becomes positive. Whoops, went ahead and did the math on accident. Reciprocal of the base of 2 is 1/2, and then 1/2 squared is 1/4. 2 to the negative 1, so 1/2 to the 1 is 1/2. And then 2 to the 0 power, anything to the 0 power is 1. That's that very important point that all exponential functions go through. 2 to the first is 2, and 2 squared is 4. Okay, so let's see how many we can get of these things. Horizontal stretch, so we're going to multiply those x values by 2. We're going to reflect it over the x-axis, so we need to switch my signs on my y's. Okay, so it looks like we're going to have to do a couple of these t-charts just real quick. So -4, -2, 0, 2, and 4, doing that horizontal stretch. Switching those values, so -1/4, -1/2, -1, -2, and -4. And then last but not least, let's add 3 to those y's. Okay, so the x values are good. We're happy with where they are. Let's just add 3. So -4 plus 3 is -1. 1, 2. Looks like that's going to be, I can almost go backwards easier. 3 minus 1/2 is 2.5. And 3 minus 1/4 is 2 3/4. I'm going to go ahead and leave it as a mixed fraction because we're going to be graphing, obviously. All right, let's see if we can get this horizontal asymptote first and foremost, though, before we even try to see what's happening on the graph. So let's think. I've got a horizontal asymptote that's the x-axis starting out. It's at y equals 0, just sitting right there on that x-axis. If I stretch it horizontally by 2, haven't really done anything. So all it does is just widen the horizontal line, it's still going to be horizontal right there at y equals 0. Now if I reflect it over the x-axis, it is the x-axis, so it can't be reflected. So nothing has happened there. And last but not least, if I move it up 3, looks like we're going to change. So the horizontal asymptote looks like it's going to be y equals 3. So let's see if we can get the same thing by the time we draw it on the graph. Giving ourselves just an xy axis here. Let's see. 1, 2, looks like we're going from -4 to 4 on the x-axis, and not too much happening on that y-axis. So at -4, we're not quite down to -4, we're not quite up to +3, just slightly under 3. At -2, we're at 2.5. At 0, we're at 2, and at 2, we're at 1, and 4, -1. Okay, it looks like we're definitely getting really, really close to that horizontal asymptote that we're thinking about. y equals 3, so I'm going to make sure I label that. It's a line, and then this curve is just getting really, really, really close to that, but not just gonna ride parallel to it to eternity. Okay. All right, so let's go on to our next example. We just want to get one more practice graphing and doing all of our transformations. So here with our basic function, it's always going to be y equals some base number to the power of x. Well, what's sitting here to the power of x is 1/2. So that's our basic function, is 1/2 to the x. Everything else is a transformation. So let's go up inside that exponent and let's talk it out loud. First thing we want to look for is shifting, going left to right. That -1 tells me we're going to shift right 1 unit. So that means we're going to add 1 to the x's. Okay. Next thing we have up there is that minus sign. That minus sign is telling us to flip or reflect over the horizontal, so it'd be y-axis. So we got to swap the signs on our x values. Okay, that's everything taken care of up inside. So now let's go outside the function. The only thing outside the function is just that 3 sitting there in the front. And that's going to be that's everything vertical, and we take it as is. So it's going to be a vertical stretch of 3. So we're going to multiply 3 to the y's. All right. Let's see what we can do with this. Let's go ahead and go to our first t-chart. X's and y's. Again, domains are real numbers, so that means I'm just going to do the typical. -2, -1, 0, 1, and 2. So 1/2 to the -2. To make that exponent positive, we're going to flip that base. So 2 squared is 4. 1/2 to the -1. So 2 to the +1, which is 2. 1/2 to the 0, anything to the 0 power is 1. Again, that very important point that all basic graphs go through for exponential functions. 1/2 to the first is 1/2, and then 1/2 squared, let me write that a little bit better, but 1/2 squared then would be 1/4. Okay, so we've got our points. Let's go and see what kind of transformations we can make. So the first thing we're going to do is shift right 1 unit, so I'm going to add 1 to my x values. Flip over the y-axis, so that's going to have to be something different. Okay, let's just start here. Because when I flip over the x values, then I've got to switch the sign. I don't want to add 1 and then switch the signs all at once. That is too much to think and keep straight in the head, so not so much. So adding 1 would be -1, 0, 1, 2, and 3. So 4, 2, 1, 1/2, and 1/4. Okay, let's go again. That took care of that one. Next time we're going to flip over the x-axis, so I'm going to make all of those signs now negative, going from positive, negative, or negative to positive, and a vertical stretch of 3. Okay, so I'm going to multiply all those y values by 3. And that should take care of everything for us. So now it's a +1, 0, -1, -2, -3, times 3, so 12, 6, 3, 3/2, which is, 1.5, and then 3/4. All right. Well, as I erase this over here on the left, let's talk about the transformations of the asymptote. If I take a horizontal line and I move it to the right, still going to be a horizontal line, just shift it to the right. If I flip it over the y-axis, still a horizontal line. And if I stretch it vertically by 3, 0 times 3 is still 0. So it looks like we are probably going to keep it right at y equals 0. But let's check. Okay, we need to go pretty high with this. So at 1, we're way up at 12. Way up there at 12. Okay. At 0, we're at 6. Right there. The reason why this is so stretched out is because that 3 out front of our function, stretching it vertically by 3. That's why it's so crazy right now. -1, we're up at 3. -2, we're at 1.5. And -3, we're at 3/4. So yeah, you can see how this graph, it's definitely stretching, but you can see how it's coming down, getting close to y equals 0. So I'm going to draw in there. We still have our horizontal asymptote just like we thought, because even though you're stretching it horizontally and vertically, 0 times 3 is still 0. Okay, and that right there is the graph of this function after you've done all those different transformations.